Let's work some practice problems. So in this case here, we're looking at osmosis in solution. Use the definitions and diagrams in your notes to help you decide if the beakers below are hypotonic, isotonic, or hypertonic to the cell. The word solute, remember, means dissolved stuff. So that's the thing that we're talking about is the sugar, the salt, the ions, etc. Record your answer and explain in the box underneath in each diagram. So how we would approach this first is that we would take a look at each one of our beakers. So we have the solute that is given to us. So that's the amount of dissolved stuff in each of those solutions. So this part right here, which is like, let's just say our cell, because it has 20% solute, then I know that inside the beaker, or inside the cell right here, it must have 80% H2O, which I'm going to abbreviate as water, okay? Because we're putting it into a solution that has 80% solute, I know that it must have 20% H2O because those things add up to be 100. So we have 20 plus 80 equals 100. So the total amount of material inside that cell is equal to 100%. And on the outside in the solution, we have 80 solute and 20% water, which equals 100. Now we're looking for where the water moves. Remember that osmosis is the movement of water. So we have 80% in here and 20% here. Because we have water that's going from an area of high concentration to an area of low concentration, the water is going to move out of the cell. So the cell is going to shrink. And because water is leaving out of the cell, we have a hypertonic solution because it's getting really excited and water is leaving on the outside of it, right? So water is leaving. So water is going to go from 80% to the area that is 20% in the cell. So again, it's leaving the cell, and I've denoted that by the arrows here. All right, let's take a look at our next one. There you go. All right, we have 30% solute here, which means that in this cell, 30 plus what equals 100. That means that I've got 70% water. Remember, the solute is the dissolved stuff. And in this solution, I have 95% water because we have 5% solute. So 5 plus 95 equals 100. 70 plus 30 equals 100. Again, I'm trying to find out which way the water is going to move. And the water moves from an area of high concentration to an area of low concentration. So 95 is greater than 70. So water is going to move or flow into the cell. Right? So water is going to move or flow into the cell. And because water is going to move or flow into the cell, it's going to get bigger. So it's going to swell. In this case, we have a hypotonic solution because water is moving into the cell. All right, let's take a look here at our last one. 35% solute, which means that here we have how much H2O? 100 minus 35 gives us 65% water, and we have 10% solute in the solution, which means that we have, let's see if we can get this out of the way for you. There you go. Has 90% water, H2O. So we are going to go from an area of, again, high to low. All right, high to low. We have water that's 90% and water that is 65% inside the cell. Moving from an area of high to low, we know that the water is going to flow into the cell. And because it flows into the cell, it's going to swell, and we have a hypotonic solution. Oops, tonic, I just spelled tonic wrong, sorry. There you go, tonic, hypotonic solution. Let's try one more in terms of what this might look like in a blood cell. All right, so osmosis in blood cells. The blood cells below were placed in 3 different solutions. Blood cells have a solute or dissolved stuff concentration of 0.9%. All right, 0.9%. So let's take a look at what that means. Before we start off doing any of those things, take a look here. Inside the cell, we've got 0.9% dissolved stuff, which means that inside the cell we have 99.1% of H2O or water. And that's going to be the same for all of them because that's the normal blood cell. So 99.1% of water, 99.1% of water is in there. Now let's take a look, label our percentages of water found in each blood cell. We did that. We calculated it using the solute concentration given, which was 0.9%, which leaves us 99.1% of water in each of those cells. Now we're going to figure out and draw our arrows of the way that the water, because osmosis is the movement of water, and describe what will happen to our cell. So here we have 9% solute, which means that we have 91% of water, H2O. So here we have 0.9% solute, which is 99.1% water, because all we're doing is adding it up to 100. We have no solute that is in this beaker right here, which means that 100% of the liquid in this solution here, it's not even a solution because there's nothing dissolved in it, is 100% water. So we've got something like DI water that's there. Now let's figure out which way the water is going to flow in the beaker. All right, we have 91% and 99.1%. Because we know that water moves from an area of high concentration to an area of low concentration, water is going to flow out of the cell, And so the cell is going to shrink because water is leaving it. And in this case right here, we have a hypertonic solution. Let's move on to our middle one. We've got 99.1% and 99.1%. Well, there's not much happening there, right? So again, either the water is moving at an equal rate in and out of the cell, or it's not moving at all because there's no concentration gradient. So it's going to stay the same. And we have our isotonic solution. There you go, isotonic. Looking at the last one, 99.1% and 100%. We know that water moves from an area of high concentration to low concentration, and because 100 is bigger than 99.1, we're going to have water that moves into the cell. So there's my arrow here. Water is going to move into the cell, so the cell will swell or get bigger, and we have a hypotonic solution. Now you try one on your own.